we're looking at how to find probabilities for a standard normal random variable using the z-table. Here, the z-table we're using only gives us CDA values for positive values of z, and by CDA values, we mean probabilities in the form phi z is probability z is less than equal to z. Because for a standard normal random variable, we present the CDF using phi rather than f. And so we mean it represents it only for positive values of z. So for positive values of small z. So if we have negative values of z, we'll use symmetry property. So there's a two-step process I will apply here. In the first step, we'll ensure that we only have positive values of small z. If there are any negative values, we'll first use symmetry property and ensure that we only have positive values of small z. Once we only have positive values of z, we will ensure that all probabilities are in the form of CDF of z. If that, then we'll use the complement rule. So in the first step, you always ensure that you have positive values of small z. In the second step, you ensure that in the form of a CDF, because the z table will only give CDF values of positive values. So we looked at how to find a couple of probabilities to the left of the z value. Then we looked at probabilities to the right of the z value. Now I want to look at finding probabilities between two z values. So finding. So now I want to look at finding probabilities between two z values. So here we'll do one where we'll do one problem where it's between positive values, between the positive and a negative, and then between two negative values. So the first we'll do is, let's see how do we find the probability between two z values where both z values are positive. So z is greater than 1.2, less than 1.3. Let's first graph this and see how it looks. This is z, roughly if we sketch this is 0. I'm sorry, so this is 1.2, this is 1. So this is this area that we're interested in, right? This is the area. This area represents probability z is greater than 1.2, less than 1.3. If you notice, we can also if you notice, so if you notice, we can find this area as probability z less than equal to 1.33 minus z is less than 1.2, right? So from probability z is less than equal to 1.33, we're subtracting this probability z is less than 1.2 to get this area that lies between them. So this can be written as probability z less than 1.33 minus probability z less than 1.2, right? Because we're taking, basically, we're saying if we had this, right? This is 0, this is 1.2, this is 1.3. So this was the probability z is less than 1.3. From this, we're just taking out this area. Probability z is less than 1.2. So we're taking out this much. So the remaining is the probability z is between 1.2 and 1.3. So by graphing it, we can see we can write this probability as probability z is less than 1.3 and z is less than minus probability z is less than 1.2. Right, and now we can see both of these probabilities are in the form of CDF for positive values. Like we said, the first step is to ensure we only have positive values, so C here we do. Here z is 1.33, here z is 1.22, and both are in the form of CDF of z, right? In the form probability capital Z less than equal to small z, right? Where small z is some positive value. Since both of them are in the form of CDF for some positive value of z, so we can read these directly from the z table, right? So this represents, essentially, I can write this as phi 1.33 minus phi 1.2. So both are in the form of CDF for some positive value of z, which we can read from z table. Right, this can be directly read from the z table as both in the form of CDF of positive value of z. So now, if we go back and we read the z table, so let's see 1.33. Let's see for 1.33. Okay. Let's just bring it here up. Okay. So for 1.33, if we want to see, so this is 1.3 up to the first, this is the z value, and this is the z value up to the first decimal, right? 1.3. And then the second decimal place is here 1.33. So this means that we are looking at this number 0.9082, right? So this is the z value 0.9082. So if we go back, So this is 0.9082 minus, now let's see 1.2. Now for 1.2, the number up till the first decimal place is given over here. So this is 1.2 and the second decimal place is just 0. So it's this. So this is 0.8849. Right? So this is minus 0.8849. And then if we subtract this, this just turns out to be 0.023. Right, so in this way, we can find the probability between two z-values. So both z-values are positive. Now let's look at another one where one z-value is negative and one is positive. Right, so part 2 is probability z is greater than minus 1.7 less than 1. Again, let's first graph this to see what this area looks like. So this is 0, this is minus 1.7, this is 1.2. We're interested in the probability z is between minus 1.7 and 1. So this area is the probability. Remember, area under PDF gives us probability. Here we're interested in the probability z is between minus 1.7 less than 1.2. So we're interested in the area under the PDF for minus 1.7 to 1. And we know we can write this as the probability z is less than 1.2 minus probability z is less than 1.2. Because again, if you look at it like this is, for example, the probability z is less than 1. Right? This entire is this. If from this now we subtract the probability z is less than minus 1.7. Right? So if from here we subtract the probability z is less than minus 1.7, what's remaining is the probability z is between minus 1.7 and 1.2. Right? So this can be written as, so you can write this probability simply z is less than 1.2 minus probability z is less than minus 1.7, which is the same argument we used here, right? Probability z is between 1.2 and 1.33 was the probability z is less than 1.33 minus probability z is less than 1. Similarly, probability z is between minus 1.7 and 1.2 is the probability z is less than 1.2 minus probability z is less than minus 1.7. Now this probability is already in the form of CDF of a positive value z. I can write this as phi 1. Right? So this is already in that form because see over here we already have it in that form, right? Because remember the goal is that when you're finding probabilities of a standard normal random variable using the z table we have, we want it in the form of CDF for positive values. Here's already the first thing we check is it's a positive value z, which it is, and you then sees it in the form of CDF for z. Both things are true, right? So it is written in the form of CDF of a positive value z. So I can write it as phi 1. The issue comes in the second probability. Here you have a negative value. See, whenever you're finding probabilities using the z table that we're using, the first step is to ensure that you only have positive values itself. For any negative values of z, we use the symmetry property. Right, so here we're going to use the fact that z table that we're using does not have CDF value. Z table does not have CDF values for negative values, right? It does not have for negative values of z. So use symmetry property. So we're going to use symmetry property where we know the normal random variable is symmetric around its mean, which means that for standard normal random variable with mean 0, it's use symmetry property. It's symmetric around its mean 0. So use symmetry property of normal distribution. So let's apply that here. We know this is like this. This is z, this is 0, this is minus 1. This is the area we're interested in, right? So this area is the probability z is less than minus 1.7, right? And by symmetry, this is the same as this area, 1.7. Because see, the whole idea over here is symmetry property says that the standard normal variable is symmetric around its mean z. So probability z is less than minus 1.7 is the same as probability z is greater than 1.7. So if I draw it here again, the area that we're interested in is essentially this, right? We're interested in this area, probability z greater than 1.7. So this is the area which is probability z greater than 1.7, right? So by symmetry, I can write this as minus probability Z great. Okay, so let's just write it a little over here. This is phi 1.2 minus probability Z greater than 1.7. But the issue is still not resolved yet. See, we said the first step is to ensure that you only have positive values of Z. So over here we have a negative value Z, we use symmetry property. Now we do have a positive value Z, but there's another issue here now. We have a greater than, right? So the first step is to ensure that you only have positive values of Z. So we had a negative value Z, so we use symmetry property and got a positive value Z here. Once you only have positive values of Z, then you make sure it's in the form of only CDF of Z. Here it's not in the form of CDF of Z, so we're going to use the complement. So the idea is that Z table only has CDF values of Z. Z table only has CDF values of Z. Right? So now rewrite this in terms of CDF of Z. So we want to rewrite this, and for this we can use the complement rule. For which which we can then read from the Z table. Because remember the Z table we're using has CDF values for positive values, which can then be read from Z table. Right, so how will we write this in terms of how will we write this in terms of that? This is phi 1.2 minus. So I can write probability Z greater than 1.7 is 1 minus probability Z is less than 1.7, right? So probability Z greater than 1.7 using complement rule can be written as 1 minus probability Z is less than 1. So this can be written as phi 1.2 minus 1 plus phi 1.7, right? So now we can read both of these from the Z table. We finally have both in terms of CDF of Z. So now we can read from Z table. Right, because see, the goal is to get it in terms of CDF for positive values of Z, because that's the Z table that we're using here. Phi 1.2 we just found in the earlier part as phi 1.2 we just found here 0.8849. So let's just write it from here. 0.8849 minus 1 plus phi 1.7. Okay, phi 1.7, let's just go back and read it from the Z table. If we go back here, so we know this is 1.7, right? This is the Z value up to the first decimal place, and then the second decimal place is just 0. So this is 0.9554. 0.955. 0.955. And you just simplify this, and this turns out to be 0.8403. So in this way, we can find it. So first of all, you identify this probability is probability Z is less than 1.2 minus probability Z is less than minus 1. Here, this was already in the form of CDF for positive value Z, so you can just directly write it as phi 1.2, and this can be directly read from the table because this is in the form of CDF for positive values. Here, we have a negative value Z, for which we first use the symmetry property. Once you have only positive values of Z, if any probability is not in the form of CDF of Z, then you just rewrite it in terms of CDF of Z. Right? So the first step is to always ensure only positive values which you had here, you didn't have it. Here you had to use first symmetry property, and once you only have positive values of Z, you make sure they're written in the form of CDF of Z. Since that was not the case here, so we wrote it in terms of CDF using complement. And once both are in terms of CDF of positive values of Z, you will read it from the Z table. Again, we do all of this because the Z table we're using only has CDF values for positive values.